These are the notes for page 34. We're going to start off with example number 1 about the London Eye. It says that the London Eye is a huge Ferris wheel with a diameter of 135 meters, which completes one rotation every 30 minutes. So from just that information, we can talk about frequency, about how fast it is going. Remember, omega is equal to theta over t as long as theta is in radians. So we know that we have one revolution or one rotation in 30 minutes. And we also know that one revolution or one rotation is the same thing as 2 pi radians. Notice we're using 2 pi and not 360 degrees because we need theta to be in radians. When we finish that and reducing, we have that pi over 15 is going to be our frequency. That's omega. If we want to know how fast it's going, because the next part of our problem says that the riders board on the platform 2 meters above the ground while the Ferris wheel continues to move. So the Ferris wheel doesn't stop. So the question is, how fast is the Ferris wheel moving meters per minute so that this is possible? Remember that meters per minute has to do with linear speed. And linear speed is going to be, our equation is V is equal to R omega. So we have omega, we just need to R the radius. Since we know that the diameter is equal to 135 meters, then we know that the radius is equal to 67.5 meters. So our linear speed is going to be 67.5 meters times pi over 15. That's our frequency, or our omega. And when we get that, we put it in our calculator, it's going to come out to about 14 meters per minute. Think of that as 14 steps in 1 minute. So it's going pretty slow. The next question asks, express the rider's height above the ground as a function of time. So let's draw what it's looking like. What we do know is that from the ground, you have to go up a couple of meters. So there's a little platform. You get on the Ferris wheel, and then you're going to go around the Ferris wheel in a big circle till you get to the highest peak, and then come right back down till you're 2 meters. So it looks like we start here, and then we go up to our peak, and then we come back down. And notice, if you stay on there, you would continue to go back up. And so this looks like a negative cosine function. So we know that our height in terms of time will depend on a negative cosine function. So we need to find out where it starts oscillating. We need to find the middle of our circle from the ground. We need to find this height. Notice this is our radius of 67.5 plus the 2 from the platform. We know that this line, which is what we call our trig axis, is going to be the equation y is equal to 69.5 meters. Remember, that's the radius plus the platform. So we have our trig axes. We also know the amplitude, that once we are here, our lowest point, then going up to our highest point, that's like finding the amplitude. So our amplitude is actually our diameter, our radius of 67.5 meters. The next thing we need to know is our omega. How fast is it spinning around? Which we found earlier to be pi over 15. We do not have a phase shift, so phi over omega is equal to 0 because we're not moving it left or right. We're just going up and down in terms of our height. So we can come up with our equation by using I'm going to use h of t, the height in terms of function. Height as a function of time is going to be 69.5, that's our trig axis, minus our 67.5, that's our amplitude, negative because we talked about a negative cosine. So I need cosine, and then I need my frequency, pi over 15 t, and t is our time. So this is our equation for our height. The next thing it asks us is that when is the observer 100 meters above the ground? So we want to know the time when the height is equal to 100. we want to know when does that happen. So with my equation, I'm going to let h equal to 100 is equal to 69.5 minus 67.5 cosine pi over 15t. So I'm going to solve for t. I'm going to do that by subtracting the 69.5, and I get 30.5 negative 67.5 cosine of our pi over 15t. Then I'm going to divide both sides by negative 67.5. Using my handy-dandy calculator, I find that to be negative 0.452, and that's equal to the cosine of pi over 15t. I need to get rid of cosine, so what I'm going to do is I'm going to get the inverse cosine of both sides. So I have inverse cosine of a negative 0.452 is equal to the inverse cosine of cosine. Those go away, and that just gives me pi over 15t. Solving for t, I need to multiply by the reciprocal, and I find that t is equal to 15 over pi, the inverse cosine of negative 0.452. And we can stick this in our calculator, and we find that t is equal to 9.74 minutes, because we found our time. So we know it does that, but let's take a look again at our graph or our picture of our Ferris wheel. Notice we have this one at 69.5, so 100 must be up here somewhere. But notice it happens once here and once over here. So it took us 9.74 minutes, about 10 minutes to get up to here. And then we did some more time up here, and then we know it's going to take us about 10 minutes to come back down. Before looking for the other time slot, let me go back to our circle, our unit circle, and remind you that when we're taking the inverse functions, we don't get both answers in our unit circle. So if we take off the inverse sine function, it will actually give me an angle between negative pi over 2 and positive pi over 2, because that covers both the positive sign and the negative sign. So I highlighted that to remind me that if I'm looking for inverse sine, that's the angles that it's going to give me. This also works for inverse tangent. For inverse cosine, our calculator will give you an angle between 0 and pi. So if you are looking for the inverse cosine, it's going to be the blue highlight. So when we did ours, we only found one answer, but notice we can find the other one by finding the angle on this side. So it's actually plus this part and then the negative of that. So what does that mean to us? It means that when we found t is equal to 9.74, that the other t is actually a negative 9.74. Well, we can't go back in time in terms of a negative time, but we do know that it has to deal with those 30 minutes. So to find the other time, we're going to get our full cycle of 30 minutes, and we're going to add or subtract, however you want to see it, that 9.74 minutes. And we're going to find that the next time on the way down is going to be 20.26 minutes. So what happens in terms of our wheel is that it's going up, it takes us about 10 minutes, and then we're up here for about 10 minutes, and then we come back down for about 10 more minutes. So it happens around 10, and it happens again around 20. So that's pretty interesting. The next question and the last question says, when and what is the highest the observer will be? So we know it's going to be at this point here, halfway through our Ferris wheel ride. So that means at t is equal to 15, that's half of 30. That's when it happens. And then let's go on ahead and put it into our equation to see what the maximum height is. So when I do that, h of t, that's what we're looking for, is 69.5 minus 67.5. And let's see what happens when we plug in 15 for t. The 15 and the 15 go away and I get pi, and cosine of pi is -1. So I got to multiply this by a -1. That just means I get 69.5 plus 67.5, and that will tell me my full height, which is 137 meters. Now, we could have figured that a different way, right? We know from the picture it was 2 meters plus the entire diameter. So we actually knew that without using our equation, but it's good to know that our equation works for our scenario. Let's continue page 34 by doing a couple more examples of solving trig equations. So let's say we have example number 2 that says that we want to find out the tangent of x minus pi over 2 is equal to 1. So we want to know what values of x, when I subtract pi over 2 and I get the tangent, it will equal to 1. And I want those values to be between 0 and 2 pi. Notice that I put it equal to the 0 but not at the 2 pi. So those are going to be our values. So the first thing I'm going to do is take the inverse tangent of both sides. So when I take the inverse tangent on this side, I get x minus pi over 2. And over here, I get the inverse tangent of 1. Well, what is the inverse tangent of 1? And again, we can take a look at our unit circle. Notice tangent is equal to 1 right here. So the inverse tangent is pi over 4. Notice it only gave me that one, but there's another one on the other side of my unit circle. So we'll talk about that in just a second. So we found this to be x minus pi over 2 is equal to pi over 4. But remember, it also happens on the other side, pi away. So it also happens here as well as pi over 4 plus pi. And again, we can change this part to 5 pi over 4 and pi over 4. Those are our values for x minus pi over 2. So we're going to get each one individually. So x minus pi over 2 can equal to pi over 4. And x minus pi over 2 can equal to 5 pi over 4. Solving for x, so x is equal to pi over 4 plus pi over 2. And I do the same thing over here. 5 pi over 4 plus pi over 2. And get the common denominator of 4. So I gives me 3 pi over 4. And over here it gets me 7 pi over 4. So these two answers are my solution. Both of them are inside of 0 and 2 pi. For example number 3, let's find values of x such that they are in between 0 and 2 pi for the equation of 3 cosine of x plus 3 is equal to 2 sine squared of x. Well, the problem that we have here is that we need to get everybody in terms of cosine or everybody in terms of sine. I don't know another way of writing cosine, but I do know another way of writing sine squared. Remember, cosine squared plus sine squared is equal to 1, so sine squared is equal to 1 minus cosine squared. So that idea is what I'm going to use. So this now becomes 3 cosine of x plus 3 is equal to 2 times 1 minus cosine squared of x. I'm going to use the distributive property, get rid of parentheses, and see what we can get. I have 3 cosine of x plus 3 is equal to 2 minus 2 cosine squared of x. So I don't know if you recognize it, but it looks quadratic. So let me put everything to the left side. So this becomes a positive 2 cosine squared of x. That's this one. I get plus 3 cosine of x. And then I'm going to go ahead and subtract 2, so I get plus 1 is equal to 0. So this looks quadratic. So let's let u equal to cosine of x. which means u squared is equal to cosine squared of x. So using substitution, our equation up there now becomes 2u squared plus 3u plus 1 is equal to 0. And I can factor that. 2u and u and 1 and 1. Everybody has to be positive. And I find that u is equal to a negative 1/2 or u is equal to a negative 1. But I don't want to know what u is. I want to know what x is. So I'm going to undo it by going back and saying u is equal to cosine of x. So negative 1/2 is equal to cosine of x, as well as negative 1 is equal to cosine of x. So now I'm going to use the inverse cosine. So I need to find the inverse cosine of negative 1/2, and that will give us our x. Or think of it like this. Cosine of what angle gives me a negative 1/2? We're going to find that twice on our unit circle. No, once at 2 pi over 3, and again at 4 pi over 3. We can get that from our unit circle. Or we can put this in our calculator, but then we're going to get decimals, so it's easier to find it on our unit circle. Let's do the same thing over here. We got to find the inverse cosine of negative 1, and that will give us x, or cosine of what angle is equal to a negative 1, and that would be pi. And we only get one answer from that. And we have found all the solutions for x. This concludes this video.